Hello friends, phenomenal day, right? How true. Welcome to our lectures today. And in our lectures today, we're going to be dealing with binomial theorem. Binomial theorem. Now, in dealing with binomial theorem, we studied introductory concepts in the first and the second video. The very first of them was the factorial, which we studied, and the second was the combination. We're going to apply both of those lectures in this lecture today. Please do well to check out those videos, okay? Now, the binomial theorem is a theorem that helps us to evaluate the algebraic expansion of the powers of a binomial. It helps us to evaluate the algebraic expansion of the powers of a binomial. Suppose we were given a plus b squared, right? And we're told to expand this expression. We would simply have it that a plus b multiplied by a plus b. That is what it's going to be, right? And very well, most of us know that we can use each bracket to multiply the other, right? A multiplies A and B, A multiplies B. What we have is that this first A multiplies this entire second bracket, right? So this first A multiplies this entire bracket plus this positive B also multiplies the entire bracket. It also multiplies the entire bracket. So this gives us A plus B, A plus B. So here we have it that A times A gives us A squared, A times B gives us positive AB, positive AB. Now we are done with this bracket. We move on to the next bracket. Positive B multiplied by E here gives us positive AB, positive AB. Now positive B multiplies positive B here gives us positive B square, positive B square. How true, how true. So we can add up this AB in the middle, right? And it gives us A square plus 2AB plus B square. A square plus 2AB plus B square. That's what we have. But it gets a bit complicated when you are told to evaluate things to the extent of A plus B raised to power 3. It gets a bit complicated because you have to be multiplying long expressions. So this is where the binomial theorem comes in. The binomial theorem helps us to expand brackets, right? It is also called binomial expansion. It helps us in the expansion of these binomials. For example, we could have A plus B raised to power 3, A plus B raised to power 4, A plus B raised to power 10. It will be a lot difficult if we are opening up the brackets in this manner. It will be a lot difficult if we are opening up brackets in this manner. This is where the binomial theorem comes to place. Now, what would then be the formula for the binomial theorem? For the binomial theorem now, if we're given A plus B raised to power n, right? A plus B raised to power n, whereby n is a positive integer, right? N is a positive integer. Now, this would give us that the formula for the binomial theorem would be the summation from r equal to 0 down to n, summation from r equals to 0 down to n of n combination r multiplied by a raised to power n minus r multiplied by b raised to power r. That would be the general formula for the binomial expansion. Binomial expansion. I will be demystifying this in the next couple of videos, right? Demystify this in the next couple of videos. this would be the general formula for the binomial expansion. Let's play with some few examples and let's see how it goes. Now, suppose we are given a plus b raised to power 3. A plus b raised to power 3. How do we handle this whole piece, right? Comparing with our formula, we will see that 3 represents n, right? 3 represents n. So this gives us that we're going to start from 0 according to our formula and increase till we get to n. The formula says the summation from r equals to 0 down to n. So this would be the summation from r equal to 0 down to 3, right? Summation from r equals to 0 down to 3 of 3 combination 0 multiplied by a raised to power 3 minus 0. So we are following the formula strictly, right? So it says n combination arrow. Now when n is 3, arrow starts from 0. So arrow begins to increase from 0 down to 3, right? From 0 down to 3. So wherever we see n in the formula now, we substitute 3 and we keep on increasing the values of arrow down till we get to 3. Now in this part of the formula, we start by saying n minus arrow according to the formula, right? So it's going to be 3 minus 0. So what this means is that we're going to set our n to be 3 because it is 3 in the question, right? And we're going to keep on increasing the values of arrow till we get to 3. So let's continue. This gives us b raised to power 0 because arrow is 0 plus 3 combination 1. 3 combination 1. Now our arrow is 1 multiplied by a raised to power 3 minus 1 multiplied by b raised to power 1 since our arrow has increased to 1. So this would be plus 3 combination 2, right? Multiplied by a raised to power 3 minus 2. Now 3 minus 2 multiplied by b raised to power 2. Now the last part would be plus. Now we will notice that the value of our arrow keeps on increasing. Now we are at 2 now and we must get towards 3, right? So this gives us 3 combination 3 multiplied by a raised to power 3 minus 3. So the formula says n minus arrow, so we're going to do 3 minus 3 since our n was set to 3 and our arrow has increased to 3. So multiplied by 3, right? So let's open that whole piece up and let's see how it goes. Now this gives us now 3 combination 0. Please do well to check our video out on the combination. So let me solve this out. Gives you 3 factorial divided by 3 minus 0 factorial multiplied by 0 factorial, right? So this gives us 3 factorial divided by 3 minus 0 gives us 3, so this gives us 3 factorial multiplied by 0 factorial, right? So this goes, and in the last video we proved that 0 factorial is 1, right? 0 factorial is 1, so this is 1 over 1, right? So this gives us 1. That would be what 3 combination 0 gives us, to give us 1. So in this part of our question now, we are going to have 1. The next part, a raised to power 3 minus 0. So 3 minus 0 gives us still the very same 3. So that would be a, let me put that in the bracket for now, raised to the power 3. So b raised to the power 0 still becomes 1 also, right? Because anything raised to the power 0 gives us 1. So that gives us plus. Now we're moving on here. 3 combination 1 now. 3 combination 1. This would give us 3 combination 1. This gives us 3 factorial divided by 3 minus 1 factorial. 3 minus 1 factorial multiplied by 1 factorial. So 3 minus 1 here gives us 2, right? So this gives us 3 multiplied by 2 factorial divided by 2 factorial times, now 1 factorial gives us 1, right? So that would be 1. So this goes, and this would give us 3 over 1, giving us 3. So that gives us that 3 combination 1 is 3. Now a raised to the power 3 minus 1 here gives us 2. So that would be a raised to the power 2. B raised to the power 1 still remains b raised to the power 1. So b raised to the power 1, right? So we don't need to write that one there. Plus, now 3 combination 2, right? 3 combination 2. Let's evaluate that and let's see how it goes. 3 combination 2. That gives us 3 factorial divided by 3 minus 2 factorial multiplied by 2 factorial. So here this gives us 3 factorial, I'm writing that again, divided by, now 3 minus 2 now, right, gives us 1 factorial, so that would be 1 factorial multiplied by 2 factorial. So at the numerator we have 3 times 2 factorial. This 3 factorial, we can also choose to write it as 3 times 2 factorial. Please, I refer you to our previous video on the combinations, and you will understand more of how we are evaluating these combinations. Now 3 times 2 factorial giving us 1 factorial at the denominator times 2 factorial. So this factorial can cancel out this factorial, right? And in the end we are left with 3 over 1, which gives us 3, right? How true. So we have 3. This part of the equation, 3 combination 2, gives us 3. Now a raised to the power 3 minus 2. 3 minus 2 here gives us 1. That is a raised to the power 1. So we can go ahead and just write a, right? Now here we have b raised to the power 2. So we're going to write b raised to the power 2. Now 3 combination 3 now. Let's evaluate that quickly. 3 combination 3 gives us 3 factorial divided by 3 minus 3 factorial multiplied by 3 factorial, right? So this gives us 3 factorial divided by 3 minus 3 here gives us 0 factorial. Now 3 factorial here still becomes 3 factorial. So this cancels out and this cancels out. Now remember, right, we were able to prove that 0 factorial gives us 1. So this becomes 1 over 1, right? This has cancelled, giving us 1 all over there, right? And this would give us 1, right? So let's slot that into our equation and let's see how it goes. So there we have it. We have that 3 combination 3 gives us 1, right? How true. Now here we have a raised to the power 3 minus 3, right? So that gives us a raised to the power 0, So let's write out a raised to the power 0. Now b raised to the power 3 still remains b raised to the power 3. Now let's clean this up and let's see how it goes. 1 times a raised to power 3 still gives us a raised to power 3, right? Plus, now 3a squared b still remains 3a squared b, a squared b, plus 3a b squared still remains 3a b squared, right? Plus, now 1 times a raised to power 0. Now it's worthy of note that you understand that a raised to power 0 still remains 1, right? Because anything raised to power 0 gives you 1. So in the end, we have 1 times 1 here times b cubed, right? And all we have there gives us b cubed, b cubed, b cubed. There you have it, guys. This is how we can evaluate questions using the binomial expansion, the binomial theorem. So this is just the introductory concept, right? Please click on the next video. We're going to be continuing the lecture in the next video. That's my time, guys. Remember, knowledge will change your life forever. How true? Knowledge will change your life forever. Thank you so much for watching, and please do leave a like for us, and please do subscribe and do ring the notification bell to get more of our content. Thank you very much. See you in the next video.